Sherman DeForest will give the next talk. Please take your seats, please.
Well, ever since we first looked at data from ATS-5 as synchronous, we've been wondering about the correlation between what happens every day up there and what happens on the ground. And we have tried doing several types of correlations. And today I'm talking about a particular day when the Convair 990 flew a grid pattern underneath the nominal foot of the ATS field line. The data I'll be presenting will be primarily photometer data that was taken by Ether and Mindy, and I'll refer to some all-sky camera pictures by Akasofu that were on the same flight. Can we have this a little bit larger? Can you make the image larger? I guess not. Well, there we go. I want to get us oriented first. I only have a few slides, and I'll be showing the same slides over and over. So if you don't pick everything up the first time around, we'll get it later. I want to get us oriented in the day. This is a normal spectrogram with zero energy in the middle, infinite energy for protons at the bottom, infinite energy for electrons at the top. Okay, that's much better. We plot things in this way so that we can follow electric fields and see their effects on the particles. Our detectors go from 50 kilovolts to 50 volts. On this day, can you people see this gray in here, the back? Okay. Well, normally what we'd have would be a long trail like this. This is the remnant of a previous injection of particles that took place about 12 hours previously. Coming in. As we're around, local midnight is right here. We're in the pre-midnight. This is a remnant of a previous injection. I want to call your attention to two things. One is this little hump here and the very low energy electrons. A little spike, which you probably can't see, but we'll see in a later slide. And then this change in the slope of these particles. Okay. Now, those of you who are at the Chapman Symposium know the McElwain and Mauck paper that this right here represents the transition of a boundary. Next slide. Oh, sorry. This is a slide that McElwain presented. He's determined where the boundary between the cold and the hot plasmas are by looking at many, many different days' worth of data and applying electric fields. What's happened is that we're coming around this area. It's been very quiet for a long time. Something very, very slight happened in the magnetosphere and pushed this boundary in beyond us. And that's what that little churn was. The little blurb you saw first, right here, this is on a bigger scale. This little blurb was perhaps an initial compression and relaxing and another compression. Okay, these are very tiny things that happen before midnight. We go on towards midnight, and we see this big, massive injection of particles here. It's a normal, actually I said massive, it's a normal mild substorm type injection that we see several times a day. This one happens to be right near local midnight for us. We're looking at the parallel detectors here. There's a few other things I should point out. I'll come back to this later. This feature here is due to differential charging on board the spacecraft. Every active night during the winter season, we see some type of differential charging. Perhaps some of you can see a slight modulation in the protons here. That's a beating of the data taking versus a spin modulation, which is also due to differential charging. Notice that was injection here and another injection a little bit later, which tends to be saturated out on the spectrogram. I'll show a line plot showing this in a few moments. Okay, so the general feeling we have for the day is injection back here, very quiet, perhaps a mild contraction here, followed by a change here. These particles go on up, big injection here, another injection following it. During this mild time, the proton traces are slowly going up. From this, we can sort of infer that the clouds are moving inwards as we go around, or if you wish, they're stationary and we're moving out, essentially, through the clouds. But very gentle, nothing really drastic happening. This is on the expanded time scale again, the same detector. I wanted to show this feature here, the differential charging, a little better. Particularly this feature here. I'll come back to that in a few moments. Yeah, this is the pattern flown by the Convair 990. Doesn't make too much sense in those coordinates. So I take the same coordinates, replot it. This is L versus magnetic time. Now you see it makes a little more sense. Data taking actually starts right about here, coming down. I've labeled several times here where certain spikes were seen in the photometers. Just sort of keep these in mind as to where we were when those spikes are, and I'll show the data in a moment. Another feature of this flight path is that ATS-5 is right about here, and as we will see, there's an arc associated with that major injection, which sort of goes from here to here. So at times, the aircraft flies out of the arc, and we'll see that in a moment. For convenience, I've labeled the bottoms of several of these points, and you'll see in this slide that those points correspond with certain minima. This is H beta. So we're flying south now. This is time going this way. We come into the region of the arc. The H beta picks up. We fly down, go out of the arc, and turn around, come back up, etc. So if we just look at the peaks here, the H beta is sort of constant throughout. All right. The rest of these will give us various types of electrons, and by taking ratios of these intensities, we can get a handle on what the energy of the electrons producing this light is, in addition to the total intensities. The first surprising thing we see is this very mild event. This slight compression is changing. Early in the day has a lot of light associated with it. Goes on, not too much activity. This injection is exactly timed with when we see particles. I have 2-minute resolution on this photometer data to within 2-minute accuracy. This sudden takeoff here exactly coincides to when we say the particles appear asynchronous. Same thing here. Now, the interesting thing is, these particles, if I take the ratios of the various intensities, are in the order of 10 to 20 kilovolts, something on that order. The only change in the spectra asynchronous was in 100-volt electrons, as you saw. These particles over here look very similar to these. You can tell just by looking at the graphs that the ratios are going to be similar. Yet these particles, as you also saw from the graph, asynchronous are associated with 20 to 30 kilovolt particles. So apparently 2 different processes make these 2 different spikes. They look very similar to the photometer. For the particles, they look entirely different, but have roughly the same sort of characteristics. All right. There's a decrease here. Then there's a series of other spikes. Now, remember the picture of the flight path. This is on the way back going north again, and it's about a nominal value of L equals 8. This one was maybe L equals 7, something like that. Okay, here's the same data from the spectrogram, only now instead of in spectrogram format, I plotted 2 integrals. This is the number flux and the energy flux. I've labeled them E perp, P perp, E parallel, P parallel. Notice that in the number flux, we see tremendous changes during this initial hump. By the way, the aircraft was very far north, about L equals 9 at this time. And there's no reason why they should see something in the aircraft like we see. This hump right here, this change, is exactly coincident with that early spike. In the energy flux, there's no sign of this. Well, maybe just a teeny tiny hump. You see, what this is telling us is that everything is in the low energy particles at that time. Okay, we go over here and look at the other event. Goes up, it has a sudden change with the injection and builds up. And then we have these other subsidiary injections taking place with slowly tailing off in the total energy flux. In the number flux, notice there's nothing really, well, this is about the only thing that corresponds with those last 3 spikes. To reorient you, like I say, I want to have all these slides over and over again. The first 2 spikes were up here, and there's only 10 minutes, like between here. So while the aircraft made its turn and came down, we were seeing that initial compression. the photometers record nothing up in here. It's just sort of flat. Come down here. They get in the range where we are. We see a change in the particle spectra. They see it. We come down here. There's a uniform arc, proton arc across here. We see sort of uniform, nothing protons going on. That's what they see. The initial injection takes place here for the big substorm. Then going around and around, those last three spikes were up here as you're sort of getting out of the range where you might expect correlation again. Okay, let's take a look just at these for a moment now. Notice that in the integral fluxes we saw nothing to correspond to this, by the way. This might very well be that the aircraft is going north and has left the main arc, went further north, something else happened. Okay, so we did not see this reflected in the particle population. But looking just at these now, at this time, I'm only going to show the results of one of these, but at each one of these three spikes, things happen on ATS-5. And this is a 1 minute average spectrum of what happens on ATS-5. This is electrons, perpendicular, parallel, perpendicular, parallel. A minute before, the spike was not there. This was a nice Maxwellian distribution, exactly like this one. At the same time that spike happens on the ground photometer, this nearly monoenergetic electron spike appeared. In terms of a number flux, this dominates everything else. You have to divide by energy to get number flux. This is a large number flux at a couple hundred volts. But that spike was produced by tens of kilovolts types of electrons. Big mystery. The protons, both before and after those spikes, did not change. Okay. So this looks really neat. Looks like these particles might be coming back up through a potential hill like Dave Evans talked about this morning. Numbers work out very, very nicely. There's also some other numerology which I should have mentioned, in that the total energy flux that we see agrees very, very well with the total energy flux or energy deposited at the ground during the substorm injection. It does not agree during that initial compression. It does agree during the substorm. Unfortunately, this thing also agrees. I say unfortunately because that comes at the time, just at the time we started differential charging. So now I'm in a quandary because that spike, can I go back to it? Yeah. The spike, which I'd like to say is some monodirectional electrons coming up the line of force, may very well be electrons spewing off an insulator, which is right near us, and we're collecting them. Okay, well, there's still some physics in it, because this spike comes and goes with the stuff on the ground. But now, what is the physical explanation? Is something on the spacecraft charging due to something on the ground, or is that really a monoenergetic beam? Now, maybe I can sort that out in the next several months, but it's going to take a lot of work. And I just throw this out to show some of the complications. How you shouldn't go running off saying, that's parallel fields. Okay, that's
I guess it may be just my own problem, but I missed one thing. There were two events where the 4278, 5577 ratio was the same. And for the first, you said you saw 100 EV particles. And the second event, you said you saw KeV particles. Is that correct?
Yeah. This is associated with 10 keV, 10 to 30 keV electrons. And the energy flux that we see of the electrons is equivalent to the total energy deposited in the atmosphere per square centimeter per everything. This thing occurs at the same time we see a bunch of low energy electrons.
About the same L?
About the same L. There's a little bit north of us here, but about approximately the same L. And the energy flux that we see does not correspond to this energy flux. It's less. So what I'm saying is there's something happening here which is totally different from what's happening over here. Now, I didn't mention the all-sky camera pictures, but Sean has sent them to me that cover this period to this period. This is a classical sort of thing. T equals 0 is right here with the brightening of the aurora, and by the time you get over here, it's patchy and all sorts of funny things happening. So this would be a classical case that he could put in his book for a classical isolated substorm. This thing over here, I've not seen yellow sky camera pictures. I'm sort of predicting there will be a southward going arc at this point. And that's intense enough that it should be seen on yellow sky pictures.
Of course, I guess what you're saying, that putting words in your mouth, that photometer data indicating that what really precipitates is the same. So in one case, perhaps the particles already have the right energy, and in the other case, the particles had to be accelerated somewhere further down the field line. Is that?
Well, I just said there's two processes. I don't think this is just fortuitous, that this should come at exactly the time that we see something happening. I think that's really physics here. These spikes come right when we see spikes. I think that process is different from this. I think this is associated with the movement of boundary that's already there. This is associated with the formation of a new boundary, a new injection.
Could you have missed? Wait a minute.
Is there any possibility that in the first event that ATS was just inside whatever new injection boundary you had, and that had you been out at 8 Earth radii, you would have seen a very strong injection like you got in the second event?
Okay. The answer is at 8, no. There could be something further out in the tail, maybe 10, something very small, like the sort of things that Gordon Rossiter sees in his highest magnetometer chains. Something like that. But within plus or minus 1 Earth radius of us, there was no injection at this time, because we would see it on the spectrogram. That is, later in the day, I would see other particles, which I could then trace back to that time.
I thought you were fairly sensitive to things happening inside and coming out to you, but not necessarily too sensitive to things happening outside it, and then that have to come.
That's not true. We can see about an Earth radius.
I think I should cut the discussion off at this stage.